This is a story about secrets, hidden truths buried by those who want to keep you in the dark. This is a story about lies, deliberate deceptions crafted to shape your reality. And this is a story about waking up, realizing you've been living under a shadow, not realizing it wasn't yours. For years, you've been told the world is round. Schools teach it. Experts repeat it. But what if I told you it's all a lie? The Earth isn't a spinning globe hurtling through space. It's a flat disk surrounded by ice walls to keep the water from falling off. No, wait, don't go. Hear me out. I know this sounds crazy, but stick with me. We've all heard it. The greatest minds have unlocked the secrets of the universe and discovered the true nature of reality. Renowned scientists and scholars have revealed the blueprint of our existence. Everything is made of atoms. These tiny particles combine to form molecules, which assemble into cells, tissues, and organs. Atoms are the building blocks of life, and understanding them unlocks the mysteries of existence. It sounds logical. It's repeated everywhere. But dig deeper and the story falls apart. What's an atom? How do we know they exist? Can we prove it? No. The concept of an atom is a model, a theory. It's a mental construct used to explain what we observe, not something we can actually see or touch. In fact, no one has ever isolated a single free atom in its pure, isolated form. They can't be observed directly. All we have are electron microscopes and scanning tunneling microscopes, instruments that allow us to image surfaces by scanning a probe across them while measuring the forces between the tip and the surface. We then interpret these readings as images of atoms, but they are just interpretations, not direct observations. Moreover, the idea of an atom is constantly changing. Democritus first proposed the idea of an indivisible particle around 400 BC. Dalton came along in the early 1800s with his atomic theory, J.J. Thomson, Ernest Rutherford, and Niels Bohr all made significant contributions, each adding new details and refining the concept. Even today, the field of quantum mechanics challenges the classical view of an atom, suggesting that they are probabilistic entities rather than miniature solar systems. The truth, atoms don't exist. Shocking, right? The evidence was hidden in plain sight, but no one wanted you to see it. Scientists have built entire careers on the theory of atoms. Universities have invested billions into their study. Entire branches of industry are based on manipulating atoms, nanotechnology, material science, semiconductor engineering, nuclear physics, and chemistry. If atoms don't exist, then none of this makes any sense. So why the lie? Was it ignorance or something darker? Follow the money, the power, and the truth becomes clear. Some theories are more equal than others. Some interpretations are more valid than others. Consider gravity. Newton gave us a theory of gravity that worked pretty well. Einstein turned that around, showing us that gravity was the effect of curved spacetime. Most people don't understand either theory, but most physicists will agree that Einstein was right. Newton was wrong. Yet every day we use Newton's laws. Every engineer designing a bridge or a satellite relies on Newton's gravity. Why? Because it works. Until we can find a way to harness anti-gravity or travel near the speed of light, Newtonian gravity will do just fine. Likewise with atoms. We may never prove they don't exist, but we can build stuff using what we observe. We can design and build computers, solar panels, nuclear reactors without relying on the idea of atoms. The pursuit of knowledge is a human endeavor, not a divine revelation. It's messy, uncertain, Prone to bias and self-interest, science doesn't reveal the truth, it advances our understanding of the truth. The truth is malleable, shaped by observation, experimentation, interpretation and consensus. It evolves with new evidence and fresh perspectives, sometimes. Progress means discarding old ideas like phlogiston, the substance that was thought to enable combustion, until it was replaced by the concept of oxygen. Sometimes progress means refining and expanding existing theories like the heliocentric model of the solar system, which replaced the geocentric model and then inspired Einstein's theories of special and general relativity. We tend to think of science as objective, a universal search for truth. But science is also a social enterprise, a human endeavor with all the biases, blind spots and fallibility that implies. Science progresses through debate, scrutiny and replication. Results are challenged, theories are modified. But it's a slow process and often incomplete. Scientists are human after all. Their understanding is limited by their own biases, beliefs, and backgrounds. They bring their perspectives to the table, influencing how they ask questions, design experiments, and interpret results. Personal beliefs can even color the way data is collected and analyzed. It's a constant struggle to stay objective. Sometimes success means admitting the limits of our understanding. There are many things we simply don't know. In some cases, what we think we know could be wrong. It's not that science is always right. It's that science is always evolving. What about Einstein? He, too, was a product of his time and place. Born in 1879 in Germany, Einstein's scientific thinking was shaped by the intellectual currents of his era. His theories were revolutionary, challenging long-held beliefs about the nature of space, time, and gravity. But they were also products of the social and cultural context in which he lived. Einstein wasn't just a genius who unlocked the secrets of the universe. He was a scientist navigating the intellectual landscape of his time. Einstein's personal experiences also played a role in shaping his views. His parents were German Jews, and he was acutely aware of the anti-Semitism prevalent in European society. This experience of discrimination likely influenced his later political activism, especially his opposition to war and militarism. His famous essay, "Why Socialism Cannot Be," addressed the impact of industrialization and capitalism on society, and his ideas about peace and pacifism were deeply rooted in his personal history. Einstein wasn't just a brilliant physicist. He was a human being whose life experiences and social context shaped his thinking. He was a product of his time and place. So when it comes to science, remember that theories evolve, interpretations differ, and understanding is always provisional. What seems right today might be refined tomorrow. That's the nature of knowledge. The quest is never ending. The journey is the destination. When Einstein developed his theory of general relativity in the early 20th century, he was trying to explain some anomalies in the observed motion of celestial bodies. Things like Mercury's orbit around the Sun didn't quite fit with Newton's predictions. Enter gravity. Einstein proposed that gravity wasn't a force, but a curvature in spacetime caused by mass and energy. Objects move along the curves in spacetime, giving the illusion of being pulled by a force. It was a radical departure from Newtonian physics, and it solved some problems, but it also created new ones. General relativity predicts the existence of black holes, regions of space where gravity is so intense that nothing, not even light, can escape. But black holes are more than just dense regions of space. They warp the fabric of spacetime. This warping affects the passage of time. Time slows down near a black hole compared to an observer far away. It's not a difference in how clocks measure time. It's a real slowing down of the flow of time itself. Time near a black hole becomes a different experience from time elsewhere in the universe. But there's a catch. General relativity also predicts that black holes must have a temperature that depends inversely on their mass. Smaller black holes have higher temperatures. This prediction doesn't sit well with quantum mechanics, the theory that describes the behavior of matter at the atomic and subatomic level. Quantum mechanics suggests that black holes shouldn't have a temperature at all. They should be perfectly black, emitting no light or heat. The conflict between general relativity and quantum mechanics highlights a fundamental problem in our understanding of the universe. We have two powerful theories that describe different aspects of nature, but they seem incompatible. Physicists are working hard to resolve this conflict by developing a theory of quantum gravity, a theory that would unite general relativity and quantum mechanics. But until then, we're left with a universe full of anomalies, paradoxes, and mysteries. The truth is out there, but it's hidden beneath layers of complexity. And the irony is that in our quest to understand the universe, we often lose sight of the simplicity that lies at its core. So who's right? Newton or Einstein? The answer, both and neither. It's not about choosing one over the other. It's about appreciating the contributions of each and understanding their limitations. Newton gave us a framework for understanding the physical world that worked remarkably well. Einstein revolutionized our understanding of space, time, and gravity, expanding the boundaries of possibility. Rather than viewing them as conflicting, we can appreciate them as complementary pieces of a larger puzzle. And maybe that's the point of all this talk about atoms and spacetime and gravity. Maybe it's not about finding the one true answer, but about embracing the journey of discovery. Maybe it's not about proving someone wrong, but about building a more complete picture of the world. After all, the pursuit of knowledge is a never-ending journey. The universe is vast and complex, and there's always more to learn. So let's celebrate the curiosity that drives us, the wonder that inspires us, and the courage to question everything. Because in the end, it's not about who's right or wrong. It's about the journey of discovery and the endless possibilities that lie ahead. Now that you know the truth, what will you do? Question everything. Share this. And never let them fool you again.